Okay, so I'm making this like right after uploading the previous video, the Vedic math one, and like, you know, yeah, I had that one made for a long time, but I just forgot to upload it. Yeah, that's the thing. So yeah, otherwise, okay, that's pretty much all I wanted to say. Wow, I am really dumb. I need social skills, don't I? Moving on. So yeah, today we'll be doing some of this average stuff. So I was just thinking about this like a while ago. You know, I don't know why, but while just thinking about sigma notation for some reason, which is going to come up by the way. Yeah. So be sure to exist. I guess till the end. I don't know what YouTubers say, man. I'm like, yeah. So yeah, it's so we know that an average of a number is 69, say, right? So we know that if we add a certain observation x to it, and then we take the average, so the sum of observation over the number of observation, that's the average, right? And if we add like a number x to the observations, then the number of observations will also increase. But we know that if this number x, say this is x1, if this is um what was I saying? Yeah, if this one is greater than the average here given, of course I've taken nice numbers everywhere because I am a nice boy. So if this is greater than our average, then we know that an average including this number would be bigger than our original average, and same goes, and similarly for a smaller one, the original average would be larger as the number is smaller, right? So I was thinking about this and I was thinking, how can I prove this? How can I generalize this? Because I am a really dumb person. Yeah. So, we know average is the sum of all observations over the number of observations. So, see the sum I in I where we'll use indexing as one, fine. Of say no, I don't want to use x here. I'm gonna use like some other variable. We've used I, we've used n, we've used sigma too technically. So yeah, capital sigma, I've used that. Ha ha ha. Joke. Am I funny? I think so. So yeah, okay, that's fine. Now we should, okay, so we'll use say a is also used. Wow, we've used a lot of variables. I'm gonna use t and this over the number of observations, which is the topmost number. Yes, that's n, right? So that we know is the average, right? That's the formula for the average. Now let's say we are creating something. Let's say a. So what we have to prove is a with an x1 added to it. No, let's call that x, right? And first we'll say x is greater than a. That's not the right a, is it? Wow, I really suck at this. So yeah, a, yeah, we'll say that this, we have to prove that this is like bigger than our original a, right? We have to prove that. That's our to prove. And we've established that here, before the video. So that's good enough. So ax greater than a, that's nice. So how will we write ax, right? So x is added to the observations, right, to the sum of observations. So we'll add an x to that one, I guess. Yeah, also like we're just assuming that x is greater than a because okay, so this is t, so let's say it's like temperature or something on those lines. So yeah, temperature is always positive, we're assuming that because we're in kelvins. Ha ha ha, nerd. So I'll write it here, right? I like congested stuff. So ax should be let's see, so our original a, and we somehow have to like isolate in a, this thing, like this is our original numerator of a, right? That's an. That's why am I using equal to sign everywhere? I am smart. Do not question my intelligence. I am smart. So yeah, we're just saying that, right? That's our numerator. That's an. And now we have to find I don't know, this part, n part, right? So n should be just n plus 1, right? Because we're just adding one observation. That's easy enough. Should I do n plus j? Should I just prove this like in general, just proved forever? No, not now. I guess I could try that like after this. That's a sequel coming up. That's a sequel, you know. Gotta save some for the sequels. Okay, so ax, right? Now from this, how can we isolate? Let's see. Can we separate the denominator? Can we factorize the denominator? Man, no, I'm really not ready to do that. I don't want to die. How can we separate denominators? I don't know. Nah, I haven't thought about this much, have I? Now for denominators is how can you? I don't know, man. Separating denominators, multiplication, I guess. I don't know, but n plus 1. That's why I said factorization. But n plus 1 is not really that much of a factorizable quantity, is it? Yeah. It really isn't. So I don't know, man. How can we prove this? Okay, I guess let's just do something, right? So, and of course here, like, all of the numbers are positive. N is obviously positive. It has to be positive. You can't have a negative number of observations. I is positive by definition. I is equal to 1, so just going on from there. T is positive because it's temperature in kelvins, as we said in the question, because I am lazy. And of course n is positive, and hence a is positive, right? So everything in this is positive, and since x is greater than a, x has to be positive. Okay, that's good enough. So I don't know, let's just like separate these two, right? These two terms, this one and this one. So I'm just gonna write here. I'm just tired now. Ax is equal to, okay, so our sigma thing, ti. Wait, I didn't write ti. Okay, I just quality content here, guys. Please subscribe. Over n plus 1, that's good enough. And then we have a plus x over n plus 1. That's cool. That does not look like an x. Wow. You see my handwriting on paper. You will, like, you know. Yeah, my handwriting is like bad. It's like bad, right? Okay, so x over n plus 1. That's now we know that this boy and this boy, right? This boy must be greater than, no, less than, sorry, less than, because the denominator is increased, right? Let's say this is let's say it is less than a, and this is less than a, right? Okay, that's a good relation. So we've added a to the equation. Okay. Yes. Now this is easy enough. Yeah. Ax equals a plus some arbitrary constant or whatever, alpha. Yeah, it is a constant. But why did I say what? I don't know why I said whatever. I don't know. Plus x over n plus 1. Now we know that this constant has to be positive, right? Alpha is positive. We know x over n plus 1 is positive because x is positive by definition, and n is positive, and 1 is obviously positive. So we can just call this stuff greater than 0, right? I guess I can call that ax equals A plus, why am I plus sign so messed up? Yeah, so A plus beta. And we know that beta is positive. Therefore, okay, so AX minus A is equal to beta. I don't know, I want like a concrete relationship like this, right? A minus A is equal to beta. And since beta is greater than 0, right, which is greater than 0. That's great actually, yeah, that's great. So AX minus A is greater than 0. It makes AX greater than 0. That is a hence. Wait, what? No. Oh, wow, I messed up really bad in the end there. God, I really hope my teachers don't see this, or they will, like, you know, come after me. You might not see another video from me, guys. I'm funny. Please subscribe. So yeah, that was convenient actually, and that's really great. Okay, now let's see. For x smaller than a, can we do x smaller than a? Okay, that's one side of it proved, right? That's just done and dusted. That's just done and dusted. That was easier than I thought it would be. So yeah, but still, an 11-minute video. Mid-roll ad. No, I can't even add ads yet. I am poor. Guys, please subscribe. Okay, so we have this stuff, right? We know AX is going to be that regardless of what X is, you know? And this is that the value of X changes. Yeah, I'm gonna call this X1, 1, 1, 1. Yeah, just add 1 everywhere now. Man, this is going to be annoying. 1, 1, 1, 1. So many ones. I don't know if I added them all now. Not really. I suck, dude. X1, wow, ones everywhere. I think that's good enough. Yeah, that's good enough. That's X1, right? Now let's take case X2. A is still the same, right? Yeah. So X2 less than A. Now, how can we prove that the average decreases, you may ask? I'm asking the same question. Wow. Haha. Soulmates. Okay, so okay, so yeah, let's just write down AX2. Yeah, subscript under subscript. Like a subscriptception. I is equal to 1 ti plus x2, you know, all this. I mean, I'm gonna put the brackets around this boy just in case I just, you know, mess up stuff. And the denominator is still going to be n plus 1, right? Yeah. So now I know that we're going to have to operate in a similar fashion to this, to this part. I just know that, right? Because I'm smart. No, wait, do we? And am I dumb? Aw, I'm dead. Okay, let's see. So, right. Let's say. Okay, so I'm just gonna distribute them. Oh wow, this looks bad. It should be a subscript, and it looks like it's getting multiplied with a. Yeah, dude. I really sometimes wonder how my teachers can check my answer sheets. I'm just gonna call this one M. You know, for. Okay. No, I can still be the same, right? I doesn't matter. Oh, I doesn't matter. Well, that's hurtful. Let's call this capital T. I don't know. Yeah, capital T. That's better. That's like, you know, so we don't confuse. Well, wait. No, N doesn't have to change. I'm dumb. No, N can stay the same. So can teach say, yeah. Because why must they change? They don't have to change. You know? Exactly what I say to my mom when I don't want to have a bath. Okay. I'm funny, guys. Subscribe. I can also say the same. I don't have to change that. Yeah, so that all that looks right. Now let's continue. Yeah, n plus 1, that's nice, over x2 over n plus 1, that's nice. That x2 is less than a. Therefore, think about this. Okay, right. So, this part, like, what about this part? You may ask, this is obviously less than a. And this part also happens to be less than a. Okay. Right? Yeah. Why did I say I don't know why. Is it actually less than a though? No. Can we see that? I think I can say that, right? I don't know. I'm gonna wait to say that. I don't know if I can say that yet. But if that were to, right? If both these were less than a, then that still wouldn't prove that. So that's just dumb, right? So say this is again, I've used alpha and beta. Wow, I should wait. Yeah, what were okay? Alpha, beta, gamma, delta. Yeah, right. Okay, gamma and delta. Okay, I'm not dumb. A, and this is less than, right? So a minus some. Wait, what was gamma? What was gamma? Wait, I don't remember my Greek letters. Noob. I'm such a noob, dude. Don't cancel me. I'm just gonna use lambda. That's the one I remember. I don't care. Doesn't matter, right? It's a arbitrary constant. Doesn't matter. So n plus x2 over n plus 1. And this is greater than 0. And we are operating in a very similar fashion to this one, if you remember. Very similar fashion. So since this is... No, wait. What? Now this is greater than 0, right? Yeah, for sure. No, it doesn't. Okay, x2 is less than a, so x2 can be negative, but we're avoiding negative values because we're talking about real life here. So is this true or is this not true? I don't know. Wait. Okay, so I'm not going to assume that yet, right? I don't think I can assume that x2 is positive. Yeah, I don't think I can. No, wait. X is indeed a value of t, right? Because that's a temperature. You can't just add random units to an average. So yeah, x is indeed a value of t. So it must be greater than 0 because t is greater than 0 because we defined it that way in the start. This is temperature in kelvins, right? So this is greater than 0. That's greater than 0. So I don't know. Wait, does that look like an O? Alright. It's oh well. Oh wait, that is a good pun. That is a good pun, dude. Oh well. Okay, that's 0. Greater than 0, sorry. Wow, I just said 0. So yeah, that's greater than 0 for sure, right? Now ax2 equals a minus some arbitrary constant lambda. Now this is greater than 0. Okay, wait, no, I don't think that's useful in the slightest, right? But if this is greater than 0, okay, maybe we need to do some like magic or something. I don't know. What? I don't believe in magic. Please don't sue me. Right. Am I too dumb for this? Okay. X2 is it's greater than 0, right? What about lambda? Well, because since we've taken lambda, since we've taken like negative here, so we can say that lambda in itself is yes. Okay, so this whole thing is indeed yep. So all that changes from this one to this one is the sign in front here. See, wow, I'm smart. Subscribe, guys. Subscribe. Don't kill me. I don't believe in magic, please. The delta. Wait, do I remember delta? Can I draw delta even? equals a, I don't know, minus delta. Minus, what was delta? Dude, it was something like that. Yeah, that's delta. Fine. Sue me, dude, it's an arbitrary constant. No, is it? Is it though? No, it doesn't. It's just equal to that. Not really arbitrary. No. Lambda was quite arbitrary, but this is not arbitrary. Oh, wait, lambda isn't arbitrary either. So, wait, yeah. Ignore every time I said arbitrary because that's, yeah, no, that was the wrong statement. It is indeed some specified constant, but it is a constant in the end, right? Yeah, so this is the relation. So now we just have to do some stuff with equations, I guess. So yeah, now we just move this one to here and this one to here. We just exchange these both, and minus and plus exchanging, leave the signs the same. So we know delta is equal to a minus ax2. That's nice. And we knew that, delta is greater than 0. Yes, yeah, that's true. So all this stuff is greater than 0. A minus ax2 is greater than 0. Moving this ax to the other side, a greater than ax2, ladies and gentlemen. Oh wow, that didn't come in frame at all, did it? Yeah, apologies. The mic drop wasn't audible. Oh, that's a good one. Yeah, mic drop wasn't audible. I'll remember that. I'll use that. As if I talk to humans. Ha ha ha. Noob. Okay, yeah. So I'll just rewrite this one like in this form. In this form, like the way we wanted to prove it, right? So ax1 is greater than a, and ax2 is less than a. When you change these, you have to like do stuff with this sign to inequalities, basic things. That's proved, and this is a very long video. Wow, that was hopefully like not so bad that you want to stab me or something. I don't know. Yeah, that's nice. Yeah, that's really nice. I did not. I should like plan my videos a little. Like most of my videos are just correcting myself. Yep. So yeah, I can dab and bye.